In this lesson, we're going to be talking about how to write a system of equations from word problems. So, before we do that, let's first define what a system is. A system is two or more equations that eventually we'll be solving simultaneously. Now, today we're just going to be looking at word problems and how we write those two equations from the word problems. We'll be talking about how to solve them a little bit later in some upcoming lessons. Let's take a look at our first example. This particular example is going to be in standard form. So just to recap real quick what standard form looks like like ax plus by equals c. So we could have word problems that are either in standard form or in slope-intercept form. So we're going to be taking a look at both of those types today. But our first example is in standard form. It says, Ben lived in France and Canada for a total period of 14 months in order to learn French. He learned an average of 150 new words per month when he lived in France, and an average of 130 new words per month when he lived in Canada. In total, he learned 1,920 new words. Write a system of equations to represent this scenario and to eventually be used to find the amount of time that Ben lived in each country. So we know that standard form uses the variables x and y. However, when we're writing equations from word problems, it's sometimes useful to pick different variables that are more aligned with the words in the problem or what we're solving for in the problem. So this asks us to eventually solve for the amount of time that Ben lived in each country. So I'm going to pick F for the amount of time he lived in France. And I'm going to select C for the time that he lived in Canada. That way, when I go to solve this eventually, I would know which number is representing the time in France and which number would be representing the time in Canada, because literally it's going to say F equals a number and C equals a number. So I know F is standing for France and C is standing for Canada. This is not necessarily required, but I think it's helpful. Before we just go ahead and start writing our equations, one of the strategies that we talked about earlier was to highlight the relevant information. So let's take a little bit of time to do that. So we know that he spent a total period of 14 months living in these two countries. We don't know how much time in France, and we don't know how much time in Canada, but we know altogether it should total 14 months. I'm going to switch colors because I notice that these other values are talking about how many words he acquired in the French language when he was living in each country. So the first one is 150 new words per month when he lived in France, 130 new words per month when he lived in Canada, and we have the idea that he learned a total of 1,920 new words. Okay, so when we write one of our equations, we want one of the equations to represent time in months, and we want the other equation to represent new words. Okay, so I'm going to put the time equation in red since I have that keyword of 14 months, total period of 14 months, identified in red. So, like we said earlier, we don't know how much time he lived in France individually, but we know that that's represented by the variable f. So, the amount of time in France plus, again, we don't know the amount of time in Canada, but we know that that's C. And we know that total means the equal to, again, 14 months was what we identified in the problem. So this equation means the amount of time in France plus the amount of time in Canada is supposed to total 14 months. All right, let's switch to the number of new words. So this first part says 150 new words per month when he lived in France. So per, hopefully we recognize that as being multiply. So we're going to multiply 150 times the number of months he lived in France. Plus, this next part says 130 new words per month when he lived in Canada. So 130 times C. And the total again was given as 1,920. So there are my two equations that again, eventually we're going to learn some strategies to solving them. But right now we're just writing those two equations. So this is my final answer. This is my system of equations that I could use to solve that particular word problem. Okay, this next example is in slope-intercept form. So again, just to recap, y equals mx plus b. That is what slope-intercept form looks like. So this particular word problem is set up so our two equations will be written in that form. Let's go ahead and read through the problem. A group of friends want to take a day-long tubing trip down a river. There are two different companies in the area that offer this service. River Rapids charges a group fee of $20 plus $5 for each tube needed. Tubing Travelers charges a group fee of $40 plus $2 for each tube needed. Write a system of equations that can be used to find how many tubes it would take for the two companies to charge the same fee. All right, again, let's start by highlighting all of the important information in the problem. So in red, I'm going to highlight anything that has to do with river rapids. So it tells me that they charge $20 for a group fee plus $5 for each tube. Okay, let's switch to Tubing Travelers. Tubing Travelers, I'm going to put in blue. It says that they charge a group fee of $40 plus $2 for each tube needed. Okay, so we need an equation to represent river rapids, and we need an equation to represent Tubing Travelers. River Rapids, I'm going to put their equation in red, and for right now, I'm just going to stick with y and x for my two variables. So y equals, it says $20 for the group plus $5 for each. That's kind of like per, so $5 per tube. So 5x per, again, means multiply. So that's the equation for River Rapids. In blue, I'm going to put the equation for Tubing Travelers. Y equals, they charge $40 for the group fee plus $2 per tube. Okay, so there's my two equations. If I wanted to leave those y and x, I could. However, sometimes you are going to see those equations in function notation. So let's talk about what each of those would look like in function notation. So this is asking us to find how many tubes it would take for the two companies to charge the same fee. So the charge for a particular amount of tubes is going to equal, for at least River Rapids, $20 for the group plus $5 per tube. So again, T is representing the number of tubes, and C is representing the charge, the fee that they're going to charge. Let's talk about tubing travelers. So the charge for a particular amount of tubes is going to be equal to $40 plus $2 per tube. So, although these equations do look slightly different, they are equivalent. One is just using y and x as our variables, and the second is using function notation. Again, I used C for charge and T for tubes. Okay, so we are at the you try slide. One of these problems is going to be in standard form, and one of the problems is going to be in slope intercept form. Pause the video here, see if you can write the two equations for each problem, and then unpause the video to get the results. Okay, here are the answers to those two scenarios. The first one, $40 charge per hour he works as a carpenter, plus $50 per hour he works as an electrician, is equal to the total amount of money earned, 1,380. This second equation is the one that students typically struggle to develop, but we don't know how many hours he worked as a carpenter, and we don't know how many hours he worked as an electrician, but we know the total is 30 hours that he worked all together. So the number of hours that he worked doing carpentry plus the number of hours he worked as an electrician is supposed to equal 30. Okay, so number one was in standard form. Number two is in slope intercept form, and I did write these in function notation. So the charge for a particular amount of months is equal to $11.25 times the number of months plus $120. And the charge for a particular amount of months is equal to $18.75 times the number of months plus $60. So the first equation is representing plan A, and the second equation is representing plan B. This concludes the notes on writing equations given word problems.